All right, what I've got here is I'd like to illustrate a simple Monte Carlo simulation that is done with some financial numbers. So what we've got here is we are expecting our revenue to be 75 million, our variable cost to be 20 million, our fixed cost to be 30 million, and so that would mean that our expected profit is going to be our revenue minus our cost, which is going to be $25 million. Now, what we want to do though is we want to add some risk assessment to this, some risk analysis. And so we are going to use a normal distribution to describe the kind of risk that can be associated with these values of revenue and costs. And so if you remember the normal distribution, of course it's symmetric about the mean, and the width of the normal distribution is defined by the standard deviation. So with the normal distribution, once you define the mean and you define the standard deviation, everything else is fixed. The normal distribution is fixed. So we are going to say that the revenue has a standard deviation of 15 million, variable cost 2 million, fixed cost 3 million. And you can look at the relative amounts. So the variable cost, the standard deviation is about 10%. For the variable cost and the fixed cost. The relative standard deviation for the revenue is 20%. So what we're saying is that there's a little bit more risk in our revenue than there is relative to our costs. And what I've done here is I've also graphed these normal distributions for the revenue, the variable cost, and the fixed cost here, so you can see that how this is illustrated, where there is a chance that we could have revenue that is much greater than or much less than the expected values, whereas the costs, they are all going to be generally plus or minus within these ranges here that are a little bit narrower. Now, for the Monte Carlo simulation, what we want to do is we want to randomly select a value of the revenue, the variable cost, or the fixed cost, and then from those randomly selected values, calculate the profit. And we want to do this a number of times. We want to do this hundreds, thousand, if not several thousand times. And then what we want to do is we want to see, well, what will our profit be? How many times will we see profit values would we expect to see profit values of, say, 25 million versus 30 million versus 5 million, or maybe even a negative profit where we're losing money? Is there a chance of that happening? That's what a Monte Carlo simulation is doing. And so what we want to do is we want to randomly generate values on the x-axis for revenue, variable cost, and fixed costs. And the way we can do that is by, since we have defined these to be normal distributions, remember that the area under the curve for a normal distribution is equal to 1. And so what that means is that once you go out to infinity here, the probability of having a value of, say, 140 million having a revenue that is 140 million or less is going to be very close to 1. What about the probability of having a revenue that is 20 million or less? Well, that is going to be very close to 0. What is the probability of having a revenue at 75 million? Well, that is going to be the area under this part of the curve, which will be 0.5 or 50%. And you can do the same kind of analysis for the costs here. So we are going to use this tool to generate our Monte Carlo simulation and our, if you want to say, randomized values of these inputs that are used to calculate the profit. So the nice thing about the Excel random number function is that it goes between 0 and 1, so I can just type random, and I can just type the random function. I can bring that down, and we have generated these random numbers. And these are going to represent the probability, which is going to be the area. And then what we are going to do is ask Excel to do the inverse of the normal distribution to give us what the value on the x-axis is going to be. So to do that in Excel, we do normal.inverse, and that is going to be the probability, which is going to be this value, and then the mean and the standard deviation. So if we do this, in this case, the probability that was randomly generated by Excel is 0.43, and so that means we are going to be on the left side of this mean here. And 0.43, that's pretty close to 0.5. That means we're going to be a little bit less than 75 million, and you can see, yes, that is going to be 72 to 73 million. And so we can just drag this down, copy and paste this down. And what you can see here is every time a calculation is done, Excel generates a new random number. We can also do this with F9. You can see how, when I toggle this, that the profit is going to change. You can see 22, 24 goes up to almost 50 million, down to 16 million. We can do this a number of times to figure out how our profit is going to turn out. Now what we like to do is do this a little bit more in a little bit more organized fashion. That's what the Monte Carlo simulation does, is we are going to do this calculation. Essentially, we're going to mimic hitting the F9 button 1,000 times and keeping track of all those numbers. That's what the Monte Carlo simulation will do. So what I've done is I set up a table to do this. And here I set up the trial table. We're going to do this 1,000 times. So you can use fill series to set that up. And then I'm going to populate this table with the values here. So the revenue is going to go there. The variable cost is going to go there. Fixed cost, and the profit. So again, this is the beginning of my Monte Carlo table. All I've got is one row. What I would like to do is generate 999 more rows to fill in this table. And so to do that, we use a tool in Excel. The first thing we do is we select the top row, and then I'm going to hit Control-Shift down arrow, and that's going to select the 990 cells underneath it, so I don't have to just page through. Let's go back up. So that is selected. This is my table that is going to have all the values, and I'm particularly interested in the profit. What I am going to use, go to Data, What If Analysis, and create a data table. So click on Data Table. That brings up this dialog box. Row input cell, I'm not going to use because I'm doing my calculations in columns. For column input cell, this gets a little confusing, but just trust on this. What we need to specify is we need to specify where Excel is going to do all the calculations for these columns. And we just have to specify one cell, and so I'm going to click out here to an area that's not going to be used by Excel for anything else. That's going to be U1 on this worksheet. I'm going to click OK, and what you'll see is that our values are now populated. And so this is going to show the first value, but then it's going to do this calculation 1,000 more times, or 999 more times, and it's going to record all those values in this big long table. So that's nice, but we would like a way to look at these in a little more simplified version. And so what I've done is I've created this little table here. We are going to calculate the median, mean, standard deviation, min, max, and risk of loss for the profit. And what I'm going to do is I'm going to use the aggregate function. You don't have to do this, but later on when we do internal rate of return calculations, Excel might be generating some errors because of the way that it iterates to try to solve for the internal rate of return. We want to avoid those kinds of errors in Excel. Aggregate is a way that we can do this. So aggregate, we want to calculate the median. So that is given by number 12. And then we want to tell Excel, our next option, we can tell Excel to ignore error values. So by doing that, we type 6, and then we type in our array of numbers. And so that is going to be K16 and then K1015. And there is our median value of our profit. And notice that is pretty close to the expected value because we are dealing with these normal distributions. We can do the same thing with the average or the mean. So 1, 6, K16 to K10, 15. Then we can do the standard deviation. Standard deviation, we're going to use the sample standard deviation. We don't use the population because we're just dealing with, we aren't dealing with an infinite number of values. This is a sample. 6, K16 to K10, 15. And now the minimum value. So the minimum, that's 5, 6, K16. There's other ways you can copy and paste. Let's just keep doing this. So the minimum profit, you see in this case, minus 22 million. So there is a chance that we could lose money. And the maximum, that will be 4, 6. All right, so now we have the a nice little summary table of all of these values. Another thing that would be nice to see is, well, yeah, we know that we can lose money. We know that we can make money. We know what our average or our median profits are going to be, and we have an idea of what our standard deviation could be. But what is our overall risk of loss? And so the risk of loss would be, well, what if the profit is less than 0? So what we can do is we can use COUNTIF, and we are going to look at the profit values and count the number that are less than 0. So that's K16, K10, 15. And then our criterion, that is going to be less than 0. And we need to put that in quotes with Excel syntax. And I've already got this as percent. What I forgot to do is I forgot how many total cases do we have. We have 1,000. And so we can do that. And you can see that our risk of loss, the number of times where we have a negative profit, is about 5%. All right, so that's a nice little summary table. What if we wanted to graph these? And usually we want to graph these results in what's known as a histogram. And so there are a number of ways that you can graph things in a histogram. Excel has some tools. If you go to data analysis, make sure you have your data analysis little tool pack installed. You can do histograms. Sometimes I use them, sometimes I don't. I don't necessarily like them that much. So what I have done is I have generated another table for my histogram. I like to use 20 bins of my histogram, and my bin is going to be basically how many ways I'm going to divide my range of profit. And so my 20 different bins, my bin width, what I'm going to do is I'm going to take the maximum minus the minimum and divide it by 20. So that's my bin width. Now I'm going to actually generate my bins. And so I start at my minimum, and then I take my minimum, add my width, and I get this value. I do that all the way down to where I end up with my maximum. And I want to make sure that I don't have any round off errors, and so I'm going to exactly specify this maximum profit cell. So now I have my bins for my histogram. This is going to be the values that are on my x-axis in my histogram. And then in a histogram, what we need to do is we need to calculate the number of times these values are hit within these bins. And so again, you can use automated tools, but Excel has a frequency function. And so you can see it wants the data array. So that's going to be K16 to K1015, and then it wants the bin array, and so that is this bin array. So I've got that specified. Hit return, and you can see it generates this, and then it generates an extra 0. I'm just going to do a sum just to make sure that everything checks out right. It should be 1,000, and yes, it's 1,000. The next thing we do is, a lot of times for these histograms, it's sometimes nice to see a cumulative frequency. And so to do that, there's a couple ways one can do that. The way I'll do that pretty quickly here is I'm going to take how many times we see this and divide it by the total number of simulations we have. And I've already got this formatted as a percent. So you can see that 0.1% of the time we see a profit value of minus $24.2 million. There's a couple other ways that you can do this now. And so one way you can do this is sum of whatever this is divided by, and I'll reference this cell, divided by 1,000. And we want to hold at there. So let's see how that works. And then if I've got my references done right, I can just drag this down. And you can see that by the time we get to our maximum value, that we've accounted for 100.0% of our profit instances. And so what I've done here is I have now, to make things a little quicker, we can look at the histogram that I've generated. And here's a histogram where I've got the profit bins on the x-axis, the frequency on the primary y-axis, and the cumulative frequency on the secondary axis. Let's bring this over a little bit. And so you can see that if we go back to our value, what was our risk of loss in this case? Our risk of loss was 4.7%, kind of close to 5%. So if we look at this table, we will see that, yeah, we go from minus negative profit to positive profit between 2.5% and 4.8%. So 4.7% is going to be in there. We look at our histogram and we see that, let's pull this all the way over, and it's maybe not as easy to see, but here we start at here's our negative value, here's our positive value, and this is at 4.8%. So we cross over to a from a negative profit to a positive profit pretty close to this point right here, which if we look at our calculation is 4.7%. So that is how one can do a Monte Carlo simulation with a normal distribution. If you like, you can embed the random number generation in with this normal inverse distribution function. I did not, just so that we can see and we can visualize what that random number was for each of these functions, and we can kind of take a look and say, okay, if the probability is 0.4, that is going to be below 75 million, but not that far below, and so a value of 71 million makes sense. If the probability is 0.27, that means we're going to be kind of in the pretty close to about a quarter of the area, and so that means our variable cost is going to be about 19 million. Probability of 0.23, you can see that means that our fixed cost is probably going to be somewhere around $28 million. Just a little bit easier way to visualize this. And again, there are some other ways that you can make this maybe a little bit more efficient compared to how I did it. But this gives you what you need, and at the end you can generate these histograms and illustrate and visualize what the risk is for this particular project, given the fact that you have defined what you think the spread is going to be for the revenue, variable costs, and fixed costs, and that you are modeling the spread as a normal distribution.